Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. An insurance company issues life insurance policies in 3 separate categories: standard, preferred, and ultra-preferred. Of the company's policyholders, 50% are standard, 40% are preferred, and 10% are ultra-preferred. Each standard policyholder has a probability of 0.01 of dying in the next year. Each preferred policyholder has a probability of 0.005 of dying in the next year. And each ultra-preferred policyholder has a probability of 0.001 of dying in the next year. A policyholder dies in the next year. What is the probability that the deceased policyholder was ultra-preferred? Well, anytime you have this kind of a flip that you are given the conditional probability of something given one of the pieces of the partition, and you asked the other way, one of the pieces, the probability of death here happened, what is the probability of belonging to one of the pieces of the partition? This is signaling that you are dealing with the Bayes theorem. So we label the events. That's how we usually do this. It's a bit unwise that I'm using that notation, but so be it. I call the event of policyholder having a standard policy S, where normally we denote the probability space by this. But in this case, S is the event of a policyholder having a standard policy, P is the event of a policyholder having a preferred policy, and U is the event of a policyholder having an ultra-preferred policy, and D is the event that a policyholder dies. Then by the Bayes theorem, probability of U given D is, so the top has the conditional probability flipped, so probability of D given U times the probability of U. And the bottom has all of the same things as the top, but for every piece of the partition of the probability space, in this case, the pieces of the partition of the probability space are S, P, and U. If you add them all together, you get the whole probability space, and they're mutually exclusive, so they form a partition. So you write the same expression at the bottom of the formula as at the top, but for every piece of the partition of the probability space. So actually this formula is very easy to remember. The top has the conditional probability flipped versus the left-hand side, and multiplied by the probability of the second thing, the thing that is after the line. And at the bottom you have the same thing as at the top, but for every piece of the partition. And then we just plug in all the numbers, and we get 0.0141, which is answer D. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies, and good luck on the test.